Okay, dear students, we solve this problem. If a matrix A 4 2 minus 2 minus 5 3 2 minus 2 4 1, then find eigenvalues and eigenvectors for the matrix A. And also, can matrix be diagonalized? We have to check whether this matrix is diagonalized or not. First, we find eigenvalues. For eigenvalues, to find the eigenvalues, we use the characteristic equation. The characteristic equation is nothing but characteristic equation. Equation is given by determinant of A minus lambda into I, which is equals to 0. Determinant of A minus lambda I is equal to 0. This is the characteristic equation. Okay, apply this characteristic equation to this matrix. We get 4 minus lambda, 2 minus 2, minus 5, 3 minus lambda, 2 and minus 2, 4, 1 minus lambda. Okay, which is equals to 0. Okay, we solve. By solving these determinants, we get the eigenvalues. Okay, we will solve problem. This determinant. Okay, 4 minus lambda as it is into 3 minus lambda into 1 minus lambda. 3 minus lambda into 1 minus lambda minus 4 into 2. 4 2 is 8 minus 2. Is equal to 2, leaving this column and this row, minus 5 into 1 minus lambda, minus 5 into 1 minus lambda, and minus 2 into plus 2, 2 into minus plus 2 into 2, 4, then plus this is minus 2 into, leaving this column and this row, minus 5 into 4, minus 20, and minus 2 into 3 minus lambda, minus into minus plus 2 into 3 minus lambda, which is equals to 0. 4 minus lambda as it is, which implies 4 minus lambda, 3 into 1, 3, minus 3 into minus lambda, minus 3 lambda, minus lambda into 1, minus lambda, minus 3 lambda, minus lambda, minus 4 lambda, and 3 minus lambda into minus lambda plus lambda square, and minus 8, minus 2 into 5 into 1, minus 5 into 1, minus 5, minus 5 into minus lambda plus 5 lambda, plus 4, then minus 2 into minus 20, 2 3 is 6, minus 20 plus 6, we get minus 14, 2 into minus lambda, minus 2 lambda, which is equals to 0. So, 4 minus lambda as it is, 3 minus 8, minus 5, minus 4 lambda plus lambda square, then minus 5 plus 4, minus 1, minus 1, minus 1 plus 5 lambda, minus 2 into minus 40, minus into minus common, get minus into minus plus 14 plus 2 lambda, which is equals to 0. Therefore, 4 into minus 5 is minus 20, 4 into minus 4, minus 16 lambda, 4 into lambda square plus 4 lambda square, minus lambda into minus 5 plus 5 lambda, minus lambda into 4 lambda, minus 4 lambda plus 4 lambda square, minus lambda into plus lambda square, minus lambda cube, minus into minus plus 2 into 1, 2 minus 2 into plus 5, minus 10 lambda plus 2 into 40 plus 28, 2 into 2 lambda plus 4 lambda, which is equals to 0. So, first we write the higher order terms in decreasing order. Minus lambda cube, 4 lambda square gives 8 lambda square, and 16 lambda, 5 lambda minus 11 lambda, 11 lambda plus minus 11 lambda minus 10 lambda minus 21 lambda, minus 21 plus 4 minus 17 lambda, then 20 minus 20, 2 plus 28 minus 20 plus 30, it gives plus 10 is equals to 0. Therefore, lambda square, lambda cube plus minus 8 lambda square, taking minus common, then we write lambda cube minus 8 lambda square plus 17 lambda minus 10, which is equals to 0. Okay, understood? Okay, here is the third order equation. To reduce this third order equation to second order equation by using synthetic division. Synthetic division is comes like this: 1 minus 8, 17 minus 10. First, by observing, we have to find one root. Therefore, 1 is the root key for this equation. Because we substitute 1 here, we get 0. Okay, in the LHS. Therefore, lambda equals 1 as it is. 1 into 1, 1. Here, by adding this, we get minus 7. Minus 7 into 1, minus 7. Adding plus 17 and minus 7, we get plus 10. 10 into 1, we get 10. Here, minus 10, 10 get cancelled and gives 0. This term is eliminated. Then the second order equation is lambda square minus 7 lambda plus 10, which is equals to 0. Therefore, split minus 7 is splitting here. Minus 7 has lambda square minus 2 lambda minus 5 lambda plus 10 is equals to 0. Lambda square, lambda get lambda common, lambda minus 2 minus 5 lambda minus 2. Therefore, lambda minus 2 into, we factorize lambda minus 2 and lambda minus 5. So, the eigenvalues are 2 and 5. And by observing this is also eigenvalue and 1. Therefore, lambda 1 is equal to 1, lambda 2 is equal to 2, and lambda 3 is equal to 5. These are all the eigenvalues for this matrix. In the next step, we have to find the eigenvector corresponding to these eigenvalues one by one. Okay? The eigenvector. For finding eigenvector, we use characteristic polynomial. Characteristic polynomial is a minus lambda I into x. Here x is the eigenvector, which is equals to 0. The eigenvector corresponding to find the eigenvector corresponding to eigenvalue, eigenvector corresponding to the eigenvalue lambda 1 is equal to 1. Therefore, we substitute lambda 1 in place of lambda. Therefore, we get the matrix is given by 4 minus 1 minus 2, 2 minus 2 here, and minus 5, 3 minus 1, 2 as it is, minus 2, 4, 1 minus 1. X is nothing but 3 unknowns, x1 and x2, x3. Because the matrix given matrix is in the order 3. Therefore, we write 3 unknowns, and 0 is nothing but column matrix containing zeros. Okay. Then the reducible matrix is 4 minus 1, 3, 2, minus 2, minus 5, 3 minus 1, 2, 2, and minus 2, 4, 1 minus 1, 0. x1, x2, x3 as it is, and 0, 0, 0. Therefore, by multiplying this and this matrix with both matrix, we get the 3 equations. By 3 equations, we get to know what is the value of x1, x2, and x3. This is called as eigenvector, or the corresponding eigenvalue lambda 1 equals 1. Okay. So now we multiply these two matrices. Therefore, 3 into x1, 3x1 plus 2x2 minus 2x3. 3 first row column. Multiply 3 into x1, 2 into x2, minus 2 into x3. Minus 2 x3, which is equals to 0. We solve this as equation number 1. And minus 5 into x1, 2 into x2, 2 into x3. Minus 5x1 plus 2 into x2 plus 2 into x3, which is equals to 0. We call this equation as equation number 2. And the last one, minus 2 into x1, 4 into x2, 0 into x3. Minus 2x1 plus 4x2 plus 0x3, which is equals to 0. We call this as equation number 3. From the equation number 3, we get from 3, which implies we have minus 2x1 plus 4x2, which is equals to 0. Therefore, 2x1, which is equal to 4x2, 2 1s are 2 2s are. We have x1 is equal to 2 into x1. x1 here. By using 3, we get x1 value is 2 into x2. By substituting this x1 value in the equation 4, in the equation 2, we get, in the equation 2, by substituting this value, we get minus 5 x1. x1 value is 2 into x2. 2 into x2 and plus 2 into x2 plus 2 into x3, which is equals to 0. Therefore, minus 5 into 2 minus 10x2 minus 10x2 plus 2x2 plus 2x3, which is equals to 0. Therefore, minus 10 plus 2 get minus x2, which is plus x3 plus 2x3, which is equal to 0. Therefore, we write 2x3 which is equal to 8x2. 2 1s are 2 4s are. Therefore, the x3 which is equals to 4 into x2. Understood? Therefore, by using x1 is equal to 2x2 and x3 is equal to 4x2, therefore put x2 is equal to is k, then we have x1 is equal to 2 into k. Yeah, x1 is equal to 2 into k. Therefore, x3 is equal to 4 into k. Therefore, the eigenvector corresponding to the eigenvalue lambda 1 is equal to 1, the eigenvector x1 which is equal to x1, x2, x3 is nothing but 2k, k and 4k, or k is a scalar, therefore which is eliminated 2, 1, 4. This is the eigenvector corresponding to the eigenvalue lambda 1 is equal to 1. So, okay. So now we find the eigenvector corresponding to the eigenvalue lambda 2 is equal to 2. Therefore substitute in place of lambda 2. Okay. The reduced matrix is 4 minus 2 and 2 minus 2 minus 5, 3 minus 2, 2 minus 2, 4, 1 minus 2, and x1, x2, x3. We substituting lambda 2 in the place in the characteristic polynomial, get 0, 0, 0. Therefore, matrix is 4 minus 2, 2, and 2 minus 2, and minus 5, it is 3 minus 2, 1, 2. Minus 2, 4, 1 minus 2 gives minus 1. Okay? And the unknowns are x1, x2, x3. Therefore, column matrix containing zeros. Okay? Therefore, by multiplying this, we get 2 into x1, 2 into x2, minus 2 into x3. 2 into x1 plus 2 into x2 minus 2 into x3 is equals to 0. And minus 5 into x1, 1 into x2, 2 into x3. Minus 5 into x1 plus 1 into x2, 2 into x3 plus 2 into x3 which is equals to 0. And minus 2 into x1, 4 into x2, minus 1 into x3. Minus 2 into x1 plus 4 into x2 minus 1 into x3 which is equals to 0. Call this equation number 1 and 2 and this equation number 3. Okay. By solving these equations, we get the eigenvector corresponding to the eigenvalue lambda 2 is equal to 2. Therefore, how we will see from 1 and 3 we get from equation 1 and 3 we get 1 and 3 we had 1 and 3 we get 2x1 minus 2x1 goes 0, x1 2 into 2 plus 4 6 plus 6x2 and minus 2x3 minus 1x3 minus 3x3 which is equals to 0. Therefore, we write x3 as 3x3 which is equal to 6x2. Therefore, x3 is equal to 2x2. By using 1 and 3, we get x3 is equal to 2x2. We substituting by from third equation, we get substitute x3 in the equation 3, we get minus 2x1 plus 4x2 minus 1x3. x3 is 2x2 minus 2x2 which is equals to 0. 2x2, 4x2 minus 2x2 gets minus 2x1 plus 2x2. Therefore, x2 is equal to x1. We get x2 is equal to x1. Therefore, put x2 as k. Put x2 as k. Then we get x1 is equal to x2. x1 is equal to k, which is equal to x2. And x3 is equal to 2 into x2. x3 is equal to 2 into x2 is k. Therefore 2 into k. Therefore the eigenvector corresponding to the eigenvalue lambda 2 is equal to 2. We get x2 as x1 is k, x2 is k, x3 is 2 into k. Or that we get 1, 1, 2. This is the eigenvector corresponding to the eigenvalue lambda 2 is equal to 2. Therefore, so now we find the eigenvector corresponding to the eigenvalue lambda 3 is equal to 5. Substitute lambda in place of lambda 5. Substitute 5 in place of lambda in the characteristic polynomial. We get this is x2. x2 is nothing but the eigenvector corresponding to the second eigenvalue is 1, 1, 2. Column vector 1, 1, 2. So the eigenvector corresponding to the eigenvalue lambda 3 is equal to 5. Substitute. By substituting lambda in place of 5, we get the matrix is 5, 4 minus 5. Guess minus 1, 2, minus 2, minus 5, 3 minus 5 gives minus 2, 2 as it is, minus 2, 4, 1 minus 5 gives minus 4. The 3 unknowns as it is, x2, x1, x2, x3. And the column vectors containing zeros. Therefore, by multiplying these two matrices, we get equations minus x1 plus 2x2 minus 2x3, which is equals to 0, equation 1, and minus 5x1 minus 2x2 plus 2x3, which is equals to 0, equation number 2. And minus 2x1 plus 4x2 minus 4x3, which is equals to 0. We call that equation as equation number 3. Okay? Equation number 3. Therefore, from the equation 1 and 3, by adding equation number 1 and 3, we get the values x1 is 0. By adding equation 1 plus equation 2, we get equation 1 plus equation 3. Equation 3. Equation 1 plus equation 3. Equation 1 plus equation 3 minus 3x1, 2x1 plus 4x2 plus 6x2 and 2x3 minus 4x3. Okay, sorry. By adding equation 1 plus 2, we get minus 1x1 minus 5x1 gives minus 6x1. Therefore, and by adding these two goes 0 and these 2 goes 0. So minus 2x3 plus 2x3 plus 2x2 minus 2x2 goes 0, which is equal to 0. Therefore, we get x1 value as 0. Okay. So now from equation 1, we get, substituting x1 value in the equation 1, we get x1 0 plus 2 into x2 minus 2 into x3, which is equals to 0. Which implies 2x2, which is equal to 2x3. Therefore, x2 is equal to x3. Therefore, the value of x2 is same as x3. Therefore, we put x2 as k. Then we get the eigenvector corresponding to the eigenvalue lambda 3 is equal to 5 is x3 nothing but 0. x1 value is 0 and x2 and x3 is nothing but k or 0, 1, 1. This is the eigenvector corresponding to the eigenvalue lambda 3 which is equal to 5. Therefore, this is the x3 is equal to 0, 1, 1. This is the eigenvector, third eigenvector. Therefore, by these all eigenvectors, we write one matrix called matrix P. Matrix P. How? 2, 1, 1. This column matrix we write as it is 2, 1, 1 and 1, 1, 2 and 0, 1, 1. This is the matrix containing eigenvectors, set of all eigenvectors which contains theta polynomial. To diagonalize this matrix, we have the formula. If the matrix can be diagonalized, if number of eigenvectors are same as order of the square matrix, okay, and let P be the matrix and the eigenvectors are P be the matrix containing eigenvectors x1, x2, x3, which is nothing but 2, 1, 4, 1, 1, 2, 0, 1, 1. This is the matrix containing all eigenvectors. Therefore, to make this diagonalized, we have formula called P inverse. P is this P matrix and A is the given matrix and P inverse is the inverse of this matrix. To find this inverse of the P matrix, we have the formula adjoint of A, adjoint of P and determinant of. First we find the determinant of P. So determinant of P is nothing but 2, 1, 0 and 1, 1, 1, 4, 2 equals to 2 into 1 into 1, 1 minus 2 into 1, minus 2 minus 1 into 1 into 1, 1, 4 into 1, 1 minus 4, which is plus 0. 2 into minus 1, minus 2, minus 4 into minus 1 into minus 3, plus 3. Therefore, the determinant value of P is 1. Now, to find adjoint of P, adjoint matrix of P, we have the formula adjoint of P equal to cofactor of the elements, cofactor of P and transpose of that matrix. P and transpose of that matrix. Cofactor of, to find cofactor, we need the minors of this matrix. Therefore, cofactor of Aij, to find cofactor Aij corresponding Aij, we need minus 1 power I plus j and mij. Therefore, the minor element of m11 means here I is equal to 1, j is equal to 1. Minor of this element is 3 into 1 minus 4 into 2. 3 into 1, 3 minus 4 into 2, 8, we get minus 5. So m11 is minus 5. Minor of this matrix. Okay? This element. 2. 1 into 1 minus 2. m11 is equal to 1 minus 2 is minus 1. And so minor of this element is leaving this row and this column 1 into 1 minus 4. m12 1 minus 4 is minus 3. m13 nothing but this element and 1 into 2 minus 4 into 1. 2 minus 4 so to minus 2. m11 m12 m13. and M21. M21. Leaving M21 is this, leaving this row and this column, you get 1 into 1 and 2 into 0. Get M21 has 1 and M22 is equal to leaving this row and this column 2 into 1, 4 into 0, 2. M23 is equals to M23 2 into 2 and 4 into 1. 2 into 4 minus 4 is 0. M23 is 0. Similarly, M31, leaving this row, this column and this row, 1 into 2, 4 into 1, 2 minus 4 is number minus 2. Sorry. This is M31, leaving this column and this row, 1 into 1, 1 minus 1 minus 0. M31, 1 minus 0 gives 1. M32, this row and this column, 2 into 1, 1 minus 0. 1 into 0. 2 minus 0 gives 2. And M33 is equals to 2 into 1 minus 1 into 1. 2 minus 1 is 1. These are all the minor elements. Okay. Using these minor elements, if we find the cofactor of this matrix, before the cofactor of cofactor matrix is minus 1, minus 3, minus 2, 1, 2, 0, and 1, 2. This is the cofactor matrix, and this is not a cofactor matrix. Cofactor of P, by changing this sign, plus, minus, plus, minus, plus, minus, plus, minus, plus, we get adjoint of P, get minus 1 into plus, minus 1 plus 3, minus 1 into minus 3 and minus 1 plus 2, 0, 1, 1 minus 2 plus 1. The transpose of this matrix gives adjoint of P. Therefore, the adjoint matrix is adjoint of P is 1 minus 1, 1 and 3, 2, 2 minus 2, 0, 1. This means transpose means changing rows into columns. Okay, this is the adjoint of P. Therefore, the inverse of P is nothing but this is the adjoint of P. Inverse of P is nothing but is equal to adjoint of P divided by determinant of P. Therefore, adjoint of P is minus 1, minus 1, 1, 3, 2, minus 2, minus 2, 0, 1 is the matrix. And determinant of P is 1 by 1. Determinant of P is 1. Therefore, the P inverse matrix is, but P inverse is. Therefore, to test the matrix can be diagonalized or not, we have let P a P inverse, which is equals to 0. D means here diagonal matrix which contains 3 lambda values, lambda 1 and lambda 2, and other elements are zeros. Okay. If you find P inverse AP minus 1, This is the inverse of P. Okay, we have P inverse AP. P inverse AP. This is the testing the matrix, given matrix is diagonalized or not. Therefore, P inverse is this matrix, and the P matrix is the set of all eigenvectors. Therefore, P inverse is -1, -1, 1, 3, 2, -2, -2, 0, 1. So the matrix is, the P matrix is not P matrix. The given A matrix is 4, 2, -2, -5, 3, 2, and -2, 4. This is the given A matrix, and the P matrix is 2, 1, 0, 1, 1, 1, 4, 2. This is the P matrix. Therefore, matrix multiplication, by multiplying these three matrices, we get, if we get the diagonal matrix, then that matrix, given matrix is diagonalized, or else that matrix cannot be diagonalized. Okay, multiplication. First we multiply these two matrices, then -1 into 4, -1 into 4, -4, -5, 1 into -5 plus 5, 1 into -2, -2, 1 into 2, -2, -1 into -3, -1 into 3, -3, 1 into 4 plus 4, -1 into -2 plus 2, and -1 into plus 2, -2, and 1 into 1. And second row, 3 into 4, 12, and 2 into -5, -10, and -2 into -2 plus 4. 3 into 2, 3 to the 6, 2 into 3, 2 3 the 6, and -2 into plus 4, we get -8. And 3 into -2, -6, and 2 into 2 plus 4, -2 into 1, -2. And third row, -2 into 4, -8, 0 into 0, 1 into plus 0, 1 into -2, -2 into 2, -4, 0 into 3, 0, 1 into 4, 4, plus 0, plus 4, -2 into -2 plus 4, and 0 into 2, 0 plus 0, 1 into 1, and the third matrix is 1, 2, 1, 0, 1, 1, 1, 4, 2. Simplification of this matrix is plus 4 minus 4 minus 2 minus 6 plus 5 gives -1, and 2 minus 2 minus 3 minus 5 plus 4 -1, and 2 minus 2 0 and plus 1. So, -2 plus 4 minus 6 plus 16, 12 plus 4, 16 minus 10 gives 6. And 6 plus 6, 12, 12 minus 8, 4. And 6 minus 2, minus 8 plus 4, minus 4. And minus 8 minus 2, minus 10. And minus 4 plus 4 gives 0. 4 plus 1 gives 5. The third matrix is 2, 1, 0, 1, 1, 1, and 4, 2. After multiplying this matrix, these two matrices, we get 1 into 2 minus 2, and minus 1 into 1 plus 1, plus 1 minus 1, 1 into 4 plus 4. Minus 1 into 1 minus 1. Minus 1 into 1 minus 1. And 1 into 2 plus 2. Okay? Minus 1 into 0, 0. Plus minus 1 into minus 1 into 1 minus 1. 1 into 1 into 2, 1 into 1 gives 6 into 2. 6 into 2 gives 12. And 4 into 1 is 4. Minus 4 into 4 minus 16. 6 into 1 6. 4 into 1 plus 4. Minus 4 into 2 minus 8. 6 into 0 6. 6 into 0 0. 4 into 1 4. 4 into minus 4 minus 4. Minus 10 into 2 minus 20. Minus 10 into 0 into 0. 0 into 1 0. 5 into 4 plus 1. Minus 10 into 1 minus 10. 0 into 1 0. 4 into 2 plus 2. Minus 10 into 0 0. 0 into 1 0. 5 into 1 5. The P inverse A P is equal to 2 minus 1 minus 3 plus 4 and that gives 1, and minus 1 plus 2 gives 0, and 0 minus 1 plus 1 gives 0, and 12 plus 4 16 minus 16 gives 0, and 6 plus 4 10 minus 8 gives 2, and this 4 minus 2 0, and minus 20 minus 20 plus 20 0, and minus 10 plus 10 0, and finally we get 5. Therefore, this is the diagonal matrix containing eigenvalues. Therefore, P inverse AP is the diagonal matrix is equals to 1 0 0 0 2 0 0 0 5. These are all the eigenvalues 1 2 5. Therefore, the given matrix A is diagonalized. So, the given matrix is diagonalized. This is the problem. For 8 marks, you should go through it once again. Understood?